Students, we are given this question, find the cube root of 3 positive I. So this is the complex number we have been given, z is equal to root of 3 positive I. Now we are expected to find the cube root of this. So in other words, they are asking you to find root of 3 positive I raised to the power 1 over 3. Okay, now before we could obtain the cube root of this quantity, root of 3 positive I, we would represent this complex number in the form of r of cos theta positive I times sin theta. Okay, so clearly from this, r is equal to root of 3 raised to the power 2 positive 1, which is going to be root of 3 positive 1, which is going to be root of 4, which is going to be giving us 2. So this is the value of r, and alpha is going to be tan inverse of 1 divided by root 3. Of course, we can place the modulus, and that is going to be giving me pi over 6. Now this is clearly in the first quadrant, so therefore the theta is going to be pi over 6. Okay, because since the reference angle is considered, or in other words, from the given question, the location is in the first quadrant, so where theta is equal to alpha. So that's why we are getting theta to be as pi over 6. Now if I were to represent this completely, so z is going to be equal to 2 times of cos pi over 6 positive I times sin pi over 6. So this is what I've got. Now if you want to extend this result for all coterminal angles, you have to write this as cos of pi over 6 positive 2 pi k positive I times sine of pi over 6 positive 2 pi k. So this extends for all coterminal angles for a complex number of this form, root of 3 positive I. Now the question is, we are expected to find the third root of this complex number. So that's going to be 2 of cos of pi over 6 positive 2 pi of k positive I times sine of pi over 6 positive 2 pi k. This is raised to the power of 1 over 3. Okay, so that has to be obtained. Now I can rewrite this as 2 times of, in fact I can place 1 over 3 there, of cos of, this is going to be 12 positive, okay, pi positive 12 pi k divided by 6 positive I times sine of pi positive 12 pi k divided by 6. Now this is raised to the power 1 over 3. Okay, now by De Moivre's theorem, what I can do is I can rewrite this by moving. So I can state that by De Moivre's theorem, so this is going to be equal to 2 raised to the power 1 over 3 of cos pi positive 12 pi k divided by 18 positive I times sine pi positive 12 pi k divided by 18. Okay, this is by De Moivre's theorem. So students, to get the cube root, roots of root of 3 positive I, the required formula we would be using here is 2 raised to the power 1 over 3 of cos of pi positive 12 pi k divided by 18 positive I times sine of pi positive 12 pi k divided by 18. Okay, this is the formula we would be using to get the cube roots of root of 3 positive I. Now I have already given you a representation that this entire thing can be rewritten as 2 over raised to the power 1 over 3 of cis of pi positive 12 pi k divided by 18. Okay, this is simple because we can't be always representing it with such long terms. So this would simplify the result to a greater extent. Now, the values that k would be taking is 0, 1, and 2. So let us do that. So when k is equal to 0, the first root would be 2 raised to the power of 1 over 3 cis of pi positive k is equal to 0. So this term goes away, divided by 18. So I can write this as 2 raised to the power 1 over 3 of cis of pi over 18. Now, what is the meaning of this representation? Just for your clarity, this is nothing but 2 raised to the power 1 over 3 of cos of pi over 18 positive I times sine pi over 18. So that is the meaning of this representation. Okay. So when k is equal to 1, this is going to be 2 raised to the power 1 over 3 cis of k is equal to 1, so it's going to be pi positive 12 pi divided by 18. Okay, that can be rewritten as 2 raised to the power 1 over 3 cis of 13 pi divided by 18. So this is the value for k is equal to 1. Now final value k is equal to 2. So that's going to be 2 raised to the power of 1 over 3 cis of pi positive k is equal to 2 would become 24 positive, so place 24 pi there, divided by 18. I can rewrite this as 2 raised to the power 1 over 3 cis of 25 pi divided by 18. Okay, so all these constitute the solution for this question.